All right, so this is the video for exercise 5.7 interview questions. So question 1, what does the CRISP-DM methodology for data mining entail? What does the data analyst do in each step? So CRISP-DM is a structured approach to data mining and consists of 6 phases. The first is business understanding, so that's understanding business goals and priorities. In this step, the data analyst uncovers these priorities and tailors the data mining projects to support them. It's important in this step that the data analyst structures the analyses to be completed in such a way that they are relevant to the business priorities. The second step is data understanding. So here the analyst gathers data and checks it for quality issues such as missing values, duplicate values, and general inconsistencies before calculating basic descriptive statistics such as the maximum and the minimum and the average. The third step is data preparation. So here the analyst cleans the data by resolving the data quality or data integrity issues identified in the previous step, data understanding. The fourth step is model. So this is when we decide the combination of logic and algorithms to apply to a data set. Here the analyst designs a prototype model that responds to the project objectives. This is a testing and development stage, and so it's important for the analyst to very clearly document the processes and assumptions that they use so that others can check their work. Fifth stage is evaluation, and so here the prototype model that the analyst has developed is validated, reviewed and validated by other stakeholders to determine if it meets the business goals from step 1. So here the analyst has 2 real roles. First, they take feedback from these stakeholders. They also make visualizations and other types of support for the model and its outputs that they've developed. Sixth stage is deployment, and so once validated, the prototype model is then implemented into the organization and is ready for use. Question 2, so explain what needs to be done before you can forecast time series. In other words, what does time series analysis involve? Time series analysis is a process to identify patterns and trends in data in order to understand why the data looks the way it does. So this process of understanding the data, it must be completed before we can forecast time series. The main patterns and trends that we look out for are stationarity, autocorrelation, and seasonality. So stationarity is when the underlying mean and variance of a time series doesn't change over time. In other words, the data, when plotted over time, does not have an identifiable trend. It does not trend upwards or downwards during the time period. Non-stationarity, on the other hand, is the opposite. It means that the data does have an identifiable trend, either up or down over time. Autocorrelation is when the value of data points is equal at a given time interval. An example of this would be electricity usage. Electricity usage peaks during the evening when people are home, and it hits a trough during the day when they're at work, and that's kind of a regular occurrence day after day. Seasonality is when fluctuations occur in the data at regular periodic intervals. So an example would be sales increasing during the holiday season, or gasoline demand peaking during the summer driving season. This happens year after year, they're predictable trends. Each of these components, they describe the underlying pattern and trends of the data. So it's important that we have a grasp on them before we attempt to forecast the time series. It's important because, for example, the forecast of a stationary versus non-stationary data set will look meaningfully different. Question 3, so discuss the main principles of data ethics as well as what companies or organizations can do to uphold these principles. Data ethics is a very broad concept. It consists of uncovering biases in data as well as issues related to data security and privacy. So first, just uncovering biases. There are many forms of potential bias in the data that organizations collect and analyze. These include collection bias, so it means that the nature in which the data was collected resulted in bias. Sample bias, so the sample that was used to collect data is not representative of the population. There's exclusion bias when a relevant feature or factor has been excluded from the analysis. Measurement bias, so that's when there's bias in the people or machines who are actually measuring or observing outcomes. And finally, there's biased presentation of data. So, for example, when the formatting of a chart leads someone to incorrect or biased conclusions. There are also the issues of data privacy and data security. So data privacy is the laws and policies that define how organizations can collect and handle and store their data. And data security are the organization-specific techniques and processes used by an organization to comply with data privacy laws and to protect client data. The burden is on each organization to uphold the principles of data ethics by ensuring the data they collect and analyze is free of bias, and that they have strong data security protocols that are in compliance with data privacy laws. They can do this by investing significant resources into their data security program and ensuring oversight of every stage of the data collection and analysis process so as to proactively identify and minimize bias. Question 4. Imagine you're an analyst at a financial services company and you have some concerns about bias in the way a predictive model was measured. How would you raise your concerns with the manager? Make some suggestions for how to avoid measurement bias in the future. So imagining I was this analyst who had concerns about bias in the way a predictive model was measured, I would first gather as much knowledge and evidence as I can of the potential bias to ensure I have a complete picture of the issues at hand and the potential bias. Second, I would approach my manager and clearly articulate my concerns and supporting evidence, and also note the seriousness of the issue. After all, if there is bias in the model, it can have huge implications not only in just the future analysis that we run, but potentially legal ramifications on the company overall. And finally, just depending on the results of the conversation, I would plan my next steps. If my manager was receptive, I would work with them to remove or minimize the bias. If they could prove to me that it was actually a non-issue, I would thank them for instructing me. And if they were dismissive, I would potentially search for another person at the company to voice my concerns to. Second part of the question, how to avoid measurement bias in the future. There are many ways to do so. First, ensuring there are adequate controls in place during the measuring process. So, for example, multiple measuring devices. Second, designing and communicating testing procedures clearly and openly, and really inviting feedback from stakeholders to help identify bias at every stage. Third, ensuring validators have adequate experience and training, specifically as it pertains to mitigating bias. And fourth, just continuously reviewing the evaluation processes and procedures in place, including assessment rubrics, scoring rubrics, just to ensure that we're using industry standards and what the latest research says are the right tools and processes to mitigate bias. Final question, explain the difference between regression and classification models and predictive analysis. When would you use one of these models over the other? Regression models measure the relationship between quantitative variables in order to create a predictive model. And regressions show how one variable impacts another, and this relationship is then used to model future expected values. So for example, a type of regression model would be using the historical relationship between the amount of carbon dioxide in the atmosphere and the planet's temperature to model out future expected global warming rates that assume a certain amount of additional CO2 is added into the atmosphere. Classification models, on the other hand, categorize an entity, so for example, a customer, based on a set of predefined features. A type of classification model would be one used by Netflix or another streaming platform to recommend a specific movie or TV show to a customer based on the data the company has available. So this could include customer demographics, age, gender, socioeconomic status, et cetera, as well as their previous viewing trends. Regression and classification models are used for very different purposes. Regression models are used with quantitative variables to predict future expected values, whereas classification models use qualitative variables to categorize a certain entity. So I would first start with what are the data types available to me when determining which, and the goals of the analysis when determining whether to move forward with a regression or classification model.